Unpermitted work introduces potential safety hazards and can compromise the structural integrity of a building. It is unethical to jeopardize the well-being of others. As a licensed electrician, there is a duty to uphold electrical codes and regulations, which include obtaining permits for electrical work. Unpermitted work can result in fines, penalties, and even criminal charges if it leads to accidents or injuries. Instead of outright refusal, explain the risks and consequences of unpermitted work and suggest alternative solutions. For example, offer to assist in obtaining a permit or explore less invasive options for the installation. If it is believed that there is a serious safety concern, consider contacting the local building inspector or licensing board anonymously. This protects from retaliation or legal action while still alerting them to the issue. Take the time to educate the homeowner about the importance of permits and the potential risks involved. Provide them with information about the building code and the process for obtaining a permit. Let homeowners know upfront that unpermitted work cannot be performed, and explain the reasons why. Be firm in the stance, but also be respectful of the decision. While it's important to prioritize safety, it's also essential to understand that homeowners may have financial or time constraints. Try to approach the situation with empathy and compassion. Offer to help the homeowner find alternative solutions or resources. Make it clear that you are not trying to punish them, but rather protect their well-being. Engage in respectful dialogue and avoid making accusations or threats. Focus on the issue at hand and seek a mutually acceptable solution. Firstly, document your interactions with the homeowner, including the date, time, and a summary of the conversation. Secondly, keep a record of any alternative solutions that were suggested and the homeowner's response. If the homeowner insists on unpermitted work, politely decline and walk away. Your professional reputation and the safety of others should come first. Electrical safety is paramount, and adhering to the National Electrical Code, or NEC, is crucial to preventing hazards. When dealing with electrical installations, particularly concerning hot tubs, several NEC articles and sections come into play. Understanding these requirements is essential for ensuring a safe and compliant installation. Article 680 of the NEC specifically addresses swimming pools, fountains, and similar installations, which includes hot tubs. This article outlines the requirements for bonding, grounding, wiring methods, and equipment locations to minimize the risk of electrical shock. Section 680.26 details the bonding requirements for hot tubs. Bonding involves connecting all metallic parts of the hot tub and surrounding structures to create an electrically conductive path. This path ensures that all metal components are at the same electrical potential, reducing the risk of shock. This section mandates bonding of all metal parts within 5 feet, or 1.524 meters, of the hot tub. This includes metal reinforcing bars in concrete, metal piping, and metal parts of electrical equipment. Section 680.42 provides specific requirements for wiring methods used in hot tub installations. It emphasizes the use of approved wiring methods such as rigid metal conduit, intermediate metal conduit, or electrical metallic tubing. Flexible metal conduit is permitted in certain applications, but it must be properly grounded. The wiring must be installed in a manner that protects it from physical damage and ensures it is securely supported. Grounding is a critical aspect of electrical safety, and Section 680.42 also addresses grounding requirements. The grounding system must be designed to provide a low impedance path for fault current, allowing the overcurrent protection device, such as a circuit breaker, to quickly trip and disconnect the power. The equipment grounding conductor must be sized according to NEC Table 250.122, which bases the conductor size on the rating of the overcurrent protection device. Ground fault circuit interrupters, or GFCIs, are required for hot tub circuits to protect against electrical shock. Section 680.42 mandates GFCI protection for all 120 volts and 240 volts receptacles and equipment within a certain distance of the hot tub. A GFCI detects small imbalances in current flow, which can indicate a ground fault, and quickly de-energizes the circuit. This protection is essential for preventing electrocution in wet environments. The location of electrical equipment, such as receptacles and switches, is also regulated by the NEC. Section 680.43 specifies the minimum distances that electrical equipment must be located from the hot tub. Receptacles must be at least 10 feet, or 3.48 meters away from the inside wall of the hot tub, while switches must be at least 5 feet, or 1.524 meters away. These distances help prevent accidental contact with electrical equipment while using the hot tub. Overcurrent protection is necessary to protect the electrical circuit from overloads and short circuits. Circuit breakers and fuses are commonly used for this purpose. The overcurrent protection device must be sized appropriately for the circuit and must comply with NEC requirements. Section 240.4 provides guidance on the proper sizing of overcurrent protection devices. Conductors must be sized appropriately for the load they will carry. The ampacity of the conductors must be sufficient to handle the maximum current draw of the hot tub plus any additional loads on the circuit. NEC Table 310.15 provides ampacity ratings for various conductor sizes and insulation types. Proper installation and maintenance of the electrical system are essential for ensuring continued safety. Regular inspections should be conducted to identify any potential problems such as loose connections, damaged wiring, or malfunctioning equipment. Any issues should be addressed promptly by a qualified electrician. Bonding jumpers are used to connect metallic parts of the hot tub and surrounding structures to the bonding grid. These jumpers must be properly sized and installed to ensure effective bonding. The NEC specifies the minimum size for bonding jumpers based on the size of the circuit conductors. The grounding electrode system provides a connection to the earth, which helps to stabilize the electrical potential and provide a path for fault current. The grounding electrode system must comply with NEC requirements and must consist of one or more grounding electrodes, such as ground rods, ground plates, or metal underground water pipes. The NEC provides detailed requirements for the installation of underground wiring, including burial depth, wiring methods, and protection from physical damage. Underground wiring must be installed in conduit or direct burial cable that is suitable for underground use. The minimum burial depth depends on the voltage of the circuit and the type of wiring method used. Proper labeling and identification of electrical equipment are important for safety and maintenance. All circuit breakers and switches must be clearly labeled to indicate the equipment they serve. Warning signs should be posted to alert users to potential electrical hazards. Adhering to these NEC requirements is essential for ensuring a safe and compliant hot tub installation. Ignoring these requirements can result in serious injury or death. Always consult with a qualified electrician to ensure that the electrical system is installed and maintained in accordance with the NEC and local codes. Electrical shock is a serious hazard that can result in injury or death. It is essential to take precautions to prevent electrical shock when working with or around electricity. Ground fault circuit interrupters, or GFCIs, are devices that protect against electrical shock by detecting small imbalances in current flow. GFCIs are required in many areas, including bathrooms, kitchens, and outdoor locations, to provide an extra layer of protection against electrical shock. Regular inspections of electrical equipment can help identify potential hazards, such as frayed wires, loose connections, or damaged insulation. These hazards can be addressed before they lead to electrical shock or other problems. Lockout-tagout procedures are used to prevent accidental energization of electrical equipment during maintenance or repair. These procedures involve disconnecting the power source and placing a lock and tag on the disconnect switch to prevent it from being turned on. Safe work practices are essential for preventing electrical shock. These practices include using insulated tools, wearing appropriate personal protective equipment, and avoiding contact with live electrical parts. Electricity can cause fires if it is not used properly. Overloads, short circuits, and ground faults can all lead to electrical fires. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect against electrical fires by interrupting the flow of current when an overload or short circuit occurs. Smoke detectors are essential for providing early warning of a fire. Smoke detectors should be installed in every bedroom and on every level of the home. Regular maintenance of electrical equipment can help prevent electrical fires. This includes checking for loose connections, damaged wiring, and other potential hazards. Surge protection devices protect against voltage spikes that can damage electronic equipment and cause fires. Surge protection devices should be installed at the main electrical panel and at individual outlets to protect sensitive electronic equipment. Proper use of extension cords and power strips can help prevent electrical fires. Extension cords and power strips should not be overloaded, and they should be used only temporarily. Permanent wiring should be installed for long-term use. Arc fault circuit interrupters, or SIs, are designed to protect against arc faults, which are a common cause of electrical fires. SIs detect arc faults and quickly de-energize the circuit, preventing a fire from starting. Electrical codes and standards provide guidelines for safe electrical installations. Adhering to these codes and standards is essential for preventing electrical fires. Proper grounding helps to prevent electrical fires by providing a path for fault current to flow back to the source. This allows the overcurrent protection device to quickly trip and disconnect the power, preventing a fire from starting. Electrical safety training is essential for anyone who works with or around electricity. This training should cover topics such as electrical hazards, safe work practices, and the use of personal protective equipment. Preventing unpermitted work is critical for ensuring electrical safety and compliance with regulations. Unpermitted work poses a significant risk to public safety and can have serious consequences. Unpermitted electrical work often bypasses important safety inspections, which can lead to hazardous conditions that are not identified or corrected. These conditions can include improper wiring, inadequate grounding, and overloaded circuits, all of which increase the risk of electrical shock, fire, and equipment failure. Licensed electricians are trained to adhere to established electrical codes and standards such as the National Electrical Code, or NEC, to ensure that electrical installations are safe and compliant. Unpermitted work may not meet these standards, resulting in substandard installations that pose a risk to occupants. Obtaining permits for electrical work provides oversight and accountability, helping to ensure that installations are performed correctly and safely. Permit applications are reviewed by qualified inspectors who verify that the proposed work meets applicable codes and standards. Regular inspections during the installation process help to identify and correct any deficiencies before they become a hazard. Unpermitted work can lead to legal and financial consequences for homeowners, contractors, and property owners. Fines, penalties, and legal action may be imposed for violations of electrical codes and regulations. Insurance coverage may be denied if unpermitted work is discovered, leaving property owners financially responsible for any damages or injuries resulting from the work. Unpermitted work can decrease property values and make it difficult to sell or rent a property. Prospective buyers or tenants may be hesitant to purchase or lease a property with unpermitted work due to concerns about safety and liability. Reporting unpermitted work can help protect public safety and ensure compliance with electrical codes and regulations. Local building departments and licensing boards typically have procedures in place for reporting suspected violations. Whistleblower protection laws may protect individuals who report unpermitted work from retaliation or legal action. Encouraging homeowners to hire licensed electricians and obtain permits for electrical work can help prevent unpermitted work. Educating homeowners about the risks and consequences of unpermitted work can motivate them to comply with electrical codes and regulations. Providing incentives, such as rebates or tax credits, for obtaining permits and hiring licensed electricians can further encourage compliance. Implementing stricter enforcement of electrical codes and regulations can deter unpermitted work. Increased inspections, higher fines, and other penalties can discourage individuals from performing or hiring unpermitted work. Collaborating with local building departments, licensing boards, and electrical contractors can help promote electrical safety and prevent unpermitted work. Sharing information, coordinating enforcement efforts, and providing training and education can help create a culture of compliance and safety. Prioritizing safety, obtaining permits, and adhering to electrical codes and standards are essential for protecting public safety and preventing the risks associated with unpermitted work. It is the responsibility of everyone involved in electrical installations to ensure that the work is performed safely, correctly, and in compliance with all applicable regulations. Maintaining professional integrity as a licensed electrician involves upholding ethical principles, adhering to industry standards, and ensuring the safety and well-being of clients and the public. Ethical conduct is paramount in the electrical profession, as electricians have a responsibility to provide safe and reliable electrical services. This includes honesty, fairness, and transparency in all interactions with clients, colleagues, and the public. Maintaining confidentiality and protecting client information is also essential for building trust and maintaining professional relationships. Following industry standards and best practices is crucial for ensuring the quality and safety of electrical work. This includes adhering to the National Electrical Code, or NEC, and other applicable codes and regulations. Staying up to date on the latest advancements in electrical technology and techniques is also important for providing the best possible service to clients. Providing accurate and honest advice to clients is a key aspect of professional integrity. This includes explaining the risks and benefits of different electrical solutions, providing realistic cost estimates, and avoiding conflicts of interest. Prioritizing safety and compliance with regulations is essential for protecting clients and the public from electrical hazards. Avoiding conflicts of interest and disclosing any potential biases is important for maintaining objectivity and impartiality. This includes avoiding situations where personal gain could influence professional decisions. Maintaining competence and seeking continuing education is essential for providing high-quality electrical services. This includes staying up to date on the latest codes, standards, and technologies. Seeking certifications and advanced training can demonstrate expertise and commitment to professional development. Maintaining a professional demeanor and appearance is important for representing the electrical profession in a positive light. This includes dressing appropriately, communicating effectively, and treating others with respect. Providing excellent customer service is essential for building a successful electrical business. This includes being responsive to client inquiries, providing timely service, and resolving any issues or concerns promptly and effectively. Maintaining insurance and bonding is important for protecting clients from financial loss in the event of an accident or other unforeseen circumstances. Insurance provides coverage for property damage, personal injury, and other liabilities. Bonding provides a guarantee that the electrical work will be performed according to contract and in compliance with applicable codes and regulations. Participating in professional organizations and associations can provide opportunities for networking, education, and advocacy. These organizations offer resources and support for electricians, and they can help promote the interests of the electrical profession. Maintaining a positive reputation and ethical business practices is essential for building trust and attracting new clients. This includes providing high-quality work, honoring commitments, and resolving disputes fairly and ethically.